Welcome back. Today we get to tackle the other, I guess, one of the myriad of other forces that are rapidly changing America in the 1860s and the 1870s, and that is the Industrial Revolution or the Machine Age. America is behind Europe in part because of colonial policy, in part because of the distances needed to travel, and in part because of deliberate British actions. But we are going to undergo our first industrial revolution, and Britain is already through its first, they're on to their second, and this revolution is going to be fueled by, in large part, steel, railroads, electricity, and a whole host of other industries that are going to all work complementary to each other, and they're all going to be supplied by urbanization and immigration. So it's a trifold effect making industrialization possible is that immigration and urbanization. Okay? So we'll cover a lot of that today. For now, we look at this sort of triumph of the industrial age, and you come to this man, up here in the corner, and his Menlo Park Labs, Thomas Alva Edison, and he's going to come to the stage at a time when the industries necessary to make the Industrial Revolution possible are all booming. Okay? And whether it's industrial or economic factors, the railroads, the electric industries, the steel industries, the oil industries, they all feed off each other, they thrive off each other, and of course westward expansion is central to that because you need the resources to feed these industries. Okay? So Edison here develops his Menlo Park Labs that you see down in the corner, and it was supposed to be an invention factory. You have, today we would call it a think tank or a consortium, and you bring together the smartest people that you can find. You put them in a room, you give them resources, and you say, come up with things. The policy was that they were supposed to come up with a small thing, a small invention, a small patent every couple of weeks, something big, something revolutionary every 6 months. And at that time, the levels of experimentation lead to that massive burst of creativity. And Edison is known for the incandescent light bulb and the direct current electrical systems, but there's so many other things that Edison is central to that we sometimes forget. And we sometimes forget that he is a pioneer in so many other endeavors because of the importance of the incandescent light bulb. And when you look at the outburst of activity that comes not just from Menlo Park but other labs, 1790 to 1860, you'd seen the U.S. Patent Office file maybe 36,000. By 1897, you have 22,000 filed in that 1 year alone. From the Civil War to 1930s, 1.5 million patents filed and aggressively litigated. And for the most part, it's not the numbers that we see today, but it is a massive, massive increase in productivity and industrial invention. And of course, that old adage, if you build a better mousetrap, the world will beat a path to your door. That's a key to this industrial, what we will consider the Horatio Alger myth of if you invent something and do something better, you can make your way in America. And here is how that's going to play out. But for us, the electrical industry is going to be that component. Now, Edison isn't the first to think of the incandescent light, but he's able to put the inert gases inside the bulb and develop a filament that has a lifespan long enough to be useful, bright enough to be useful. And this solves one of the scourges of the urban world, of how do you light your cities after dark. People would say, okay, kerosene lamps or whale oil lamps or, of course, candles. But those are enormous fire risks. And that was an enormous problem in our urban environments at the time. Built largely out of wood, built very close together. Once there was a fire, it's very, very difficult to stop it from rapidly spreading throughout huge swaths of the city. And so the incandescent light bulb solves enormous amounts of that problem. Now, the distribution of power is also what Edison is going to be important for, because not only do you have to develop the bulb, but you've got to find a way to consistently produce electricity in a manner that can, well, have them have them light up when they are, well, the switch is turned. 1880, he lights up the Menlo Park Labs for Christmas. People would take the carriages out to New Jersey to see the wonder that is all of these electrical lights at the time. And by 1882, he's constructing a power plant in New York, bringing electrical lights to the 85 buildings there in the Wall Street Financial District. Now, it does have one distinct drawback. He had not figured out how to solve the problem of the voltage dropping over these copper wires beyond a 2-mile radius. Transmits it across the wires. Direct current, your DC, is able to travel over only a limited distance. That's a fundamental problem unless you're going to have electrical power plants every couple of miles. Could you imagine the suburban world if we had electrical power plants throughout all of it? It was a major problem. However, Nikola Tesla in Europe had figured out how to alternate the current to make it sustainable across long distances, to put distance between your larger power plants and your consumption of that electricity. And in America, George Westinghouse purchased those patent rights so he could use higher voltage. And of course, by alternating that current, you transform it across or transfer it across these electrical lines, and you have these large round transformers that then as the electrical current is being transmitted across miles and miles of electrical wire, the transformers turn it into direct current that can be used in individual neighborhoods. Okay? So we can still see some of the remnants of that in and around our electrical grid today. Now, this embarks upon what has been famously called the current war. Edison is, a relatively nasty character in a lot of different ways. He embarks upon a massive media campaign to label alternating current as the killer current, the much more dangerous, that the higher voltage that makes it transmission possible means it was more dangerous and you shouldn't have it in your home. There is already a reticence of a lot of people of an older generation to not have that electrical current into their home. They didn't know if it was safe. They didn't know if they were going to get shocked or killed or electrocuted by touching the lights. And therefore, you have this odd story of when the White House was electrified. One of the presidents, and I think it was, what was it? It was either Cleveland or McKinley, that simply, if a light was left on and he was the last one to leave that room, he wouldn't turn it off. He was absolutely afraid of touching the switches. And so that kind of mentality was still out there. Now, Edison uses this in the media to label the alternating current in those generators and those transformers as deadly. And then he goes even further to preside over the euthanizing and the executions of, and the electrocutions of unwanted dogs. And even by 1890, the first man electrocuted by the electric chair in New York, William Kemmler. So you go to highlight how dangerous it is. We're using the killer current, the alternating current, and we're going to euthanize dogs, cats, horses, and even go after an elephant named Topsy, and there you see that image there to the right, who had killed its trainer out at Coney Island. And that's a still image. You can still find the video because Edison was a pioneer in the use of video and early moving motion pictures. And it's a film by Thomas Alva Edison where they film the electrocution of Topsy the elephant. It even went so far, and the politics of it got so great, that the newspapers labeled Kemmler's execution that he was being Westinghoused. So it's really nasty, really libelous and slanderous. But at this point, we don't necessarily have the, and I was about to say, we don't necessarily have the integrity of the news agencies that we have today, but that we had possibly 30 years ago. I'm not sure if our news today still has that integrity. Now, eventually, Edison is going to have to see the legitimacy, the viability of the alternating current, and he will merge with the Westinghouse alternating current patent ideas and create a parent company that we all know today as General Electric. But if you still live in New York, if you still live in some of those areas, Con Edison is still your electric provider up there. They've just moved away from direct to an alternating current. But it does make for some very interesting stories and some interesting years there as they try to fight that current war. So imagine all the resources that are necessary to build an electrical grid. You need all the copper, you need all the steel. And we'll address the steel here in a second. You need all the coal that runs the power plants, that produces the steam, that turns the turbines, that produces all of that. So just the sheer act of electrifying some of these areas is going to have a radical effect, not only on the industry, but also on the home life. Electricity into your homes is going to be just a game-changing creature comfort that we're going to see moving forward. Now, the steel is going to be provided by this man, Andrew Carnegie. Now, Carnegie is held up as this rags to riches kind of figure. He comes from nothing and he comes from the middle class. He doesn't exactly come from nothing. He comes from the middle class. He is an immigrant from Scotland, and Carnegie comes from Scotland and makes his way largely through industrial espionage. The Bessemer process uses, and here at the bottom right, these Bessemer converters, and it was developed by Henry Bessemer and William Kelly in Sheffield, England. Now, the Bessemer process for producing steel, high quality steel in large quantities, was the use of oxygenated air injected into these into these converters that could handle as much as 5 tons of molten steel at a time. That is going to be that economy of scale, and you'll hear that term again and again and again as we go forward. Economies of scale are going to be important. I can produce more, I can produce it faster, I can produce it at a higher quality by infusing this molten steel with highly oxygenated air that burn hotter, all of the impurities go, and you're producing, instead of iron, steel. And then there's all kinds of ways of forging it and rolling it and cold quenching it to make it lighter, make it stronger, make it much more productive. Now, these Bessemer converters, once the plans, once the ideas, once the intellectual property is taken from England, it is set up in Pennsylvania, in Ohio, in Alabama, ironically, near coal deposits. That was the key. You needed massive amounts of coal to run this. You needed massive amounts of capital. And Carnegie is going to be successful in that end, that he's able to find the startup capital, get some converters online. By the time the 1890s roll around, the US is producing more steel than the UK. We have outstripped them. And by 1900, we're producing 4 times as much steel than the United Kingdom. We simply have more resources. We have more material. We have more population. And given enough time, the unlocking of the economic potential of America is going to outstrip pretty much anyone else in the world as we go forward. Now, Carnegie is going to achieve what we will call a vertical monopoly. He's going to become the master of the steel industry. By 1900, Carnegie is producing more steel than anyone in the U.S., and he produces on his own through his company Bethlehem Steel. He produces more steel than the United Kingdom. It's nice to know that Carnegie produces more steel than the entirety of the country that innovated the process. He is the largest company in the world at that point, Bethlehem Steel, with 20,000 workers. And Carnegie becomes an example of how to apply the scientific method to industry. In that application, Carnegie is going to utilize the fullness of a scientific process to get the most out of his worker hour. By 1901, though, Carnegie is going to sell it out. J.P. Morgan makes him an offer, $500 million. That's hundreds of millions of billions of dollars. Well, it's probably 20, 30 billion dollars today. It is an enormous, astronomical sum of money, and it made Carnegie possibly the wealthiest man in the world. Now, what does Carnegie do with that? Well, he gives 325 million of it away and sets up endowments. What does J.P. Morgan do with? Well, he creates U.S. Steel. And that is, again, that vertical monopoly. He basically sets the price of steel. He sets 300 and, well, 3/5 of the steel production in the United States. Therefore, he controls the majority of that process. Now, in the industrial process, we have a few other key industries. We'll continue to talk more and more about the automobile production and Henry Ford's organizational genius, the assembly line, and Henry Ford's ability to democratize an automobile, to make it reliable, affordable, and certainly available to the rank and file of the population. And he begins the assembly line operations by 1903, 10,000 sold in 1908, 250,000 of these so-called Model Ts. You know, they talked about it. You know, you didn't have windows, you didn't have a hard top, you didn't have a heater or a radio. You could have it in any color so long as it was black. You know, through this, it was reliable, it was dependable, it wasn't luxurious, but it was easy to fix, and that's the democratization process, that it was accessible to the masses. And because there's so many other automobile custom coach and bespoke automobile makers out there on the market, think about all of the other complementary industries that are created by Henry Ford. The refining of gasoline, the production of oil, the rubber industry, the paint industry, the glass industry. Think about the building of roads. Think about the building of gas stations. Think about interstates and hotels and diners and all of the other things that cater to people who might take this automobile and drive somewhere across the road. Now, Henry Ford will get into a minimum wage for him in 1914, the so-called $5 a day plan. But the Industrial Revolution and what it does to labor is going to be one of the keys that we'll talk about as we move forward. Now, Rockefeller is going to build Standard Oil, and it feeds off of the whole nature of the automobile industry. Right? Now, by 1880, Rockefeller is going to create that monopoly that controls 90% of the refining capacity. That in and of itself is, of course, that horizontal monopoly that controls the refined oil capacity. What Standard Oil is also going to try to do is have a vertical monopoly where they have the oil wells and they pump the oil and they, of course, refine the oil and they own the gas stations. So Standard Oil is going to become this monolith, one of the first of the evil corporations that are there to dominate our lives. And the full extent of the scientific management and method is going to be brought to bear on all of it. The impact on labor is going to be devastating, but for now, the impact on production is going to be significant. Okay? Now, DuPont we think of as paint, but at this point, DuPont is going to, in the early 1800s, have a monopoly on gunpowder. They branch out into fertilizers, dyes, other chemicals, photographic film, textiles, plastics. DuPont becomes a giant company as well that expands out of that production of gunpowder into the production of other things that control those nitric acid kind of products as well. So we're going to see these monopolies start to pop up. What we don't see is a lot of southern industry. Now, southern industry is going to be problematic, not because it's centered around industrialization. It does have some problematic issues in and around. The South is going to be way behind in the Industrial Revolution for a number of different factors, mainly because tobacco and cotton remain resistive to mechanization. You can't really use mechanization for the picking of, the planting of, of cotton, the curing of, and the tending of tobacco. The one bit of industry that does find its way into the tobacco industry is going to be the cigarette rolling machine. And then from that point, you're going to see actually aggressively marketing billboards, and of course, the giving away of free samples to youth of America is going to be pioneered by the American Tobacco Company. And they're going to form cigarettes into just a national industry. But a lot of the South remains rural. A lot of it remains resistant to the Industrial Revolution. The one thing that does happen, though, is some mills are going to start, some textile mills are going to start to pop up in the South because they're no longer tied to rivers. They're no longer tied to the need for the rivers to turn the gears to the water wheels to turn the machines and the looms within. Electricity is going to solve that. And that will sort of allow you to locate your mill wherever you want. So in some of the limited areas of the South where you do have urbanized population, you'll see some mills pop up. That'll limit your transport costs of taking the cotton to the north. But for the most part, a lot of these mills are going to still continue in the north because that's where your population is. That's where you have the immigrant population that's going to wind up working in these mills. When we go forward, when we're looking at it from 1900 and beyond, you have around 400 mill towns in the South, sometimes towns popping up around them. But the majority of industrial investment is going to be in the north. The lack of resources, the lack of infrastructure, the lack of bridges and rail lines, and population. The immigrant population just simply doesn't move into the South and stay there in large numbers, changing it from a very rural to an industrial area. And hence why we have so many problems in the South. Even today, we still are seeing a large shift in a lot of industries moving into the South. Now, because of our, at times, resistance to industrial unions. But it's really only been in the last 20 years, 30 years, where you've seen a lot of large-scale industries and automobile industries moving into the South. Now, I'll give you some of the idea of some of the imagery of it. We look at up here on the upper left, you see some automobile workers working on the assembly line. If you can imagine, upper right, these are guys who work in steel mills. That's their protective clothing of the day. A leather hat, maybe a leather shirt, but that's the extent of their protection. And then on the bottom left, you see a cigarette and a cigar rolling factory. And on the right, the infamous sweatshops, sewing industries. And if you could see, you see those machined, belt machine-driven sewing machines. Central crank turned throughout the roof, and you have those leather belts running and turning the sewing machines down at the bottom. Now they're called sweatshops because you had to keep the temperature very hot. You had to keep it very humid to keep fire risk down. And if it's really dry and at times cool, the threads can sometimes break. And so you wanted that moisture, and hence the sweatshop sort of idea and that notion.